Today I'm going to start by talking about the distribution of the sample mean. Now first of all, inferential statistics. Know that most of the time we want to make a conclusion about a population, like for example, what is the mean income of individuals in the United States? Measuring every single individual in a population is often impossible, which is why we take samples, like what is the mean income of 3,000 randomly selected individuals in the United States. The first thing, the population mean, is a parameter, while the second, the sample mean, is a statistic. In inferential statistics, we seek to use statistics to estimate the value of parameters that would otherwise be difficult or impossible for us to obtain. Now, the distribution of the sample mean is a probability distribution of all possible values of a sample mean computed from a sample of size n. That sounds very complicated, so let me give you an example. In my example, a statistics class has 6 students with the ages displayed below. Construct a sampling distribution of the mean of age for samples with the size of 2. So below I have 6 ages, 18, 18, 19, 20, 20, and 21. And I want to take samples of size 2 from that. So realize here that these 6 ages are our population, which is this class, and I want to take samples of size 2. So what I'm going to do is start taking samples of 2 until I've taken all possible samples, and then I'm going to find the mean of those samples, which in this case would be the mean of 2 numbers. So I started off by taking the pair of 18 and 18, and that has a mean of 18. So what I have here is all of the possible pairs. These are actually all of the possible combinations. If you're curious how I got this, you can go back to my lecture on combinations. But that's what this is. It's all the different ways the numbers can be combined, all the ways we could take samples of size 2, and then next to that I've calculated the mean for each of those things. So first what I'm going to do here is just list all the means that we have, and with all these means I'm going to create a probability distribution like this, where I'm going to take all the means, count how many we have, and then count the probabilities associated with each of those means. So we have 6 means here, 18 through 20.5, and we can count up the frequency. It looks like we have the most 19s and the least 18s. So if you add up all those frequencies, you'll find that they add up to 15. We have 15 total sample means, and that's how I'm going to find the probability. I'm just going to divide the frequency by the total number of observations we have. So again, you can still see that the most likely thing is a 19 and the least likely thing is an 18. And now that we know the probabilities associated with each mean, I can make a histogram and show the distribution of the sample mean, which I have right there. So this is the distribution of the sample mean, and we have our original ages. If we take that population of ages and calculated the mean, we would find a mean of 19.33. And if you look at the distribution we've created, we can see that the mean is about 19.33, about 19. The most common, the most likely event in our distribution is 19, so it's a pretty accurate representation. So remember that the larger our sample size is, the closer our sample mean should be to the population mean. This is the law of large numbers. And that makes sense. I mean, if you took, let's say everyone in the population was in your sample as well, then you would have a very accurate representation of what the population mean is. The larger your sample is, the better your estimate of the population mean will be. So before I finish up here, I want to talk about also the standard error of the mean. So here I have 2 distributions. One has sample sizes of 5 and one has sample sizes of 50. To be clear, these are sampling distributions of means. So in these distributions, as sample size increases, standard deviation decreases. Because remember that as your sample size gets bigger, it's going to get closer and closer to what the actual mean is. So if you have a larger sample size, there will be less dispersion. You will have a smaller standard deviation. The standard deviation of the sampling distribution is also known as the standard error of the mean. So when you hear someone say that, it's not necessarily like an error or a mistake. They're just talking about the standard deviation of a sampling distribution of means. And I have that right there in the lower right, which is the standard deviation of the sampling distribution is equal to the population standard deviation divided by the square root of your sample size. And that's all I want to talk about here. Just remember what inferential statistics is and know how to find the distribution of the sample mean and the standard error of the mean.